It's Ms. Barai. Sorry that Mr. Seta couldn't be with you, but we got to keep on learning. So I'm going to go ahead and do this short little video. Should take us no more than about 10 minutes. Everybody at this time should have this paper in front of you. We're going to go through it together, and then you'll practice some problems on your own, and then your substitute will go ahead and give you your assignment. But these notes that you do right now will help you with your assignment, so please refer to them if you have trouble doing your work. So let's pay attention because it's quick, it's fast. If you need to go back and watch the video, I'm pretty sure the substitute will replay it. If not, then you can probably go online to my YouTube channel and find it. Just go to YouTube and type in Miss Barai. Make sure you spell my name right, and you can find it and watch it for yourself. All right, so let's start with slopes and similar triangles. Last week, and maybe even the week before, and this week, you guys have been working on slope. Remember, slope is steepness. We're looking for the steepness of lines, so we're gonna just put up here steepness. In Spanish, it's pendiente, steepness, incline. And we're going to also look to use similar triangles with this. So let's take a look at this first problem that involves Joe and Kelly. So Joe and Kelly are each trying to find the slope of the graph line below. So they're both going to work on this problem. Joe chose to use the points 0, 0, and 2, 4. So now they want us to find Joe's slope. So go ahead and follow along with me. If not, go ahead, get ahead of me. But this is, Joe's is at 0, 0, and 2, 4. 2, 4. So here's Joe's points. He used those 2 points. And what do we do to figure out the slope of Joe's line? Correct, rise over run. So it'd be 1, 2, 3, 4, and then over 1, 2. So he had his slope is 4 over 2. So if we do rise over run, 4 over 2 is going to give you, 4 over 2 will simplify to just 2. Excellent job. So right now, we're going to do Kelly's, and we're going to see what Kelly got. Kelly chose to use a different set of points. So Kelly is using 2, 4. So she's going to reuse 2, 4 just like Joe did, but she's also going to use 5, 10, which is way up here. And some of you probably already did Kelly. So Kelly did it a different way. Do you think they're going to get the same answer? Let's see. 1, 2, 3, 4, 5, 6. So she went up 6, and she went 1, 2, 3. So it'd be 6 over 3. So if we write it again over here, rise was 6, run was 3, and if we simplify 6 divided by 3 simplifies to a 2 also. So they went to 2 different points, but they got the same slope. So what do you think? Turn and talk to your partner real quick. Push pause and turn and talk to your partner. All right, so you by now have already talked to your partner. How is it that you can have 2 different starting points or 2 different locations and still get the same slope? So let's go ahead and answer these questions and see if we can come to a good conclusion. It says, how are Joe's and Kelly's slope triangles related? Well, slope triangles are these triangles that you see here that were created by doing our rise and run. So we have this slope triangle right here, and it has a height of 2 and a base of height of 4 and a base of 2. And then we have this slope triangle here that we created, and it has a height of 6 and a base of 3. So what can we conclude about those triangles? There's 2 words I want you to think about. One is congruent and one is similar. Congruent figures are the same size and the same shape, and similar figures, you should remember from last year, are figures that are the same figure but different size, and their angles are the same. In here, we can't really look at their angles, but we can tell it's the same figure. It's a right triangle, and the sizes are different. Therefore, that would make them similar triangles. Similar triangles. And what we know is that similar triangles have equivalent slopes. or have equivalent heights or proportional heights. So if we go 4 over 2 and we see 6 over 3, we can check to see if they are equivalent, if they're proportional, and we can cross multiply just to verify, just so that you can see 4 times 3 is 12. That's equal to 2 times 6 is 12. So they are proportional, which means they are equivalent. And we can see that they're equivalent because if we do, the slope is 2 over 1. If we multiply that by 2, we get one of your slopes, which is 4 over 2. Oops, I'm sorry. And if we take that slope of 2 over 1 again and we multiply that one by 3, they do give us equivalent slope. So you'll see that it's 3. So no matter what our slope was, no matter where we are on the line, we will still generate an equivalent slope, equal slopes. So what does that say about their slopes? Slopes are equal. Slopes are, we'll put the same. In this particular unit, all you got to do is just make sure you understand that any two triangles, well, it answers the next question. What can we conclude about using any 2 points on the line to find the slope? Basically, any 2 points on the same line will give you the same slope. So it doesn't matter if you take a shorter version and just go up 4 and over 2. It doesn't matter if you go up 6 and over 3. It doesn't matter if I use this point here, a totally brand new point, and go up 2 over 1, like the slope that we figured out. All the slope triangles created on that same line using any 2 points will give you the same slope. So we can conclude about using any 2 points on the same, any 2 points on the line to find the slope. We can conclude that any 2 points that you got to put in a complete sentence, that you can use any 2 points you want. And your slopes will be the same. Basically, all you have to remember, slopes will be equal or the same as long as they are on the same line. Doesn't matter the size of your triangle, the slopes, the steepness of your line will be equal, will be the same. Awesome. So now let's go down to these problems real quick. And I want you to try and create your own slope triangles on both of these problems. So right now, if substitute, if you will please go ahead and press pause and go ahead, everybody try and do this first graph and the second graph on your own, and then unpause the video so that we can continue. All right, so at this point, you probably already did your problem. It says find the slope of the line below, create slope triangles, which meant that that would have been more than one, and prove that the slopes are equivalent. So they already gave you 2 points. So they gave you one with a rise of 1 and a run of 1, 2, 3, 4. So the slope here is 1 over 4. But it said triangles, so you should have had 2 triangles. And I guess I'm going to use, you can use any 2 points. I'm going to go, I think I'm going to go with this one right here, and I'm going to use the far one, which is a bigger triangle, but they should be equivalent. That means they'll give us the same slopes. So that means this one is 1, 2 with a 1, 2, 3, 4, 5, 6, 7, 8. So we went 2 over 8. So prove that the slopes are equivalent. So let's do the rise and run for the first one. The rise, I'm going to put rise over run. So rise over run. So we're going to do the rise of the red one was 1 and the run was 4. And on the second one was the rise was 2 and it was 8 of a run. What can I do to 1 to get to 2? Multiply by 2. What can I do to 4 to get to 8? Same thing. Therefore, they are equivalent fractions. Therefore, the slope is 1/4 because our slope is always written in simplest form. So they are similar. Similar triangles did give us equivalent ratios. And if you want to check it the other way, you could cross multiply and prove that they are equivalent because that will give you 8, and this will also give you 8. Therefore,